Hi guys, today I would like to discuss about the refractive index. So what is refractive index? In a simple words, we can say refractive index is a physical quantity. Physical quantity means which we can measure. So this physical quantity which relates the speed of propagation of light in different medium. So the refractive index gives an information that light will travels with different speeds in different mediums. We know that the universe fastest person in this universe, the fastest person is light. So light speed in vacuum, light speed in vacuum or air, almost all same. Vacuum or in air, its speed is 3 times 10 power 8 meter per second. So that's why we can call him as universal fastest person. Now, if this is the speed of light in air or vacuum, if light is entering air to water, obviously the speed of light in water will be changes. Now refractive index will be gives the relation between the speed of light in two different mediums. Let's see it in detail. Imagine a case that you are running in this beach. So in this beautiful beach you are running and you are entering in water. So when you are doing this action, so you observe that in the sand we are running, and when it enters to water, what happens? Our speeds decreases. Our speed decreases. Yeah, it is due to because of the water will be opposes our speed. Similarly, exactly like that, when light is traveling in two different mediums, suppose when light is traveling in this medium and the light is entering in the water medium. So we learned that the light is refracting. So because the light speed changes, the light speed changes, and we should know that how much speed it is changing. So the ratio of these two speeds means speed of light in air and speed of light in water. Suppose if I can take here the speed of light in water, and if I take it here speed of light in air. If you write this ratio means we have to divide these two. It means speed of light in air upon speed of light in water. If you divide these two, we will get a number. Since both are the speeds, we can divide speed upon by speed. so we can get a number. So that number only we call as refractive index. Here n stands for refractive index. So this refractive index gives the relation between the two speeds in the two different mediums. Suppose if we change these two mediums. So for this experimental, let me take one of the example. So I have here a glass slab. So this is a glass slab. Now light is entering through glass slab like this. So this is a light incident ray and it is entering into the glass and it is coming out. Now here if we can draw a normal on this glass slab. Now here you can see this is angle of incidence and this is angle of refraction. So and this ray is refracted ray. And if I take this outside medium as air medium and the glass is another medium. Since glass is another medium, or I can call air as medium 1 and glass as medium 2. Since light speed is different in these two different mediums, if we can write refractive index n equal to speed of light in medium 1 upon speed of light in medium 2. So when you can divide speed of light in medium 1 upon speed of light in medium 2, that we call refractive index. But this refractive index we can say precisely. So the refractive index of medium 2 with respect to medium 1. So here we need to mention the refractive index of medium 2 with respect to medium 1. Why? Because this value will be changes medium to medium. So to understand that, I can write this as refractive index of the medium 2 here is glass and medium 1 here it is air. Glass with respect to air. Suppose in the second case, if I take an example, if I take one more example in this case, now if I kept this glass slab in water, so it means my medium 1 is water now and the medium 2 is glass itself. Now even though if light travels glass or water to glass, it refracts, it changes its speed. Now if I can write refractive index at here, now I need to write refractive index of, so let me take a good color so that you can visible it here. So I can write refractive index of glass Now here it is with respect to water. Now we have to mention that refractive index of glass with respect to water equal to speed of light in medium 1 upon speed of light in medium 2. So whenever you divide these two speed in two different mediums, then you will get a ratio. So that ratio we known as refractive index. Suppose if you take a final, in this case, you would like to find the speed of light, but in this case, you take the case at here. Now here you can observe, if you can draw a normal at here, so this is the glass and the air medium surface. Suppose this ray you can take as incident ray, angle I, and this ray becomes refracted ray. So this is a refracted ray. And if you can observe it here, the refracted ray is bending away from the normal. So that also we learn that when the light is traveling from denser medium to rarer medium, a denser medium is glass and the rarer medium is air. So light bends away from the normal. So because in the glass the speed of light is less, but when it comes to the speed of light is more. Suppose if you write the refractive index in this case, now in my case, the glass is my medium 1 and the air is my medium 2. Now if I write refractive index, now this time I will write refractive index of air with respect to glass. Refractive index of air with respect to glass. Now I can divide speed of light in medium 1 upon speed of light in medium 2. I hope you understood these three different examples of the mediums. So whenever you are dividing two velocities, two speed of light with respect to two different mediums, so this refractive index value gets changes. Okay, so what happens if you always take medium 1 as vacuum or air? If medium 1 is always vacuum or air, it means I kept a glass slab at here, and if I draw a normal, and if I am drawing a refractive index, it is bending, so like that. So in the medium 1 is air and medium 2 is glass. Now if you write that case, we can call that as refractive index can call that as refractive index or absolute refractive index. We can call that as refractive index or absolute refractive index. So its formula is speed of light in air or vacuum. They both are having almost all equal speed, but it's better to write for us speed of light in vacuum upon speed of light in given medium. So we can represent that in symbolic form. So we can call this absolute or refractive index as n equal to speed of light in vacuum. We are representing that as c upon the speed of light in a given medium. We will represent that as v. So n equal to c upon v. So this formula will use to find or to relate the speed of light in a given medium and the speed of light in vacuum and the refractive index of the given mediums. Suppose if you see NCRT, so NCRT is having a table. If you see this table from NCRT, so table 10.3 gives the absolute refractive index of some materials. So see the water equal to 1.33. So that is the refractive index of water. What does it mean? Suppose if you can write 1.33 at here, 1.33. So 1.33 equal to C upon V. So here C is air medium and the V means water medium. Now, if we can say in words, so the speed of light in water is 1.33 times less than the speed of light in air. Because if you can do the cross multiplication, C equal to 1.33 times V, you can get it. Here the V is speed of light in water. So I can say this in words. So to make equal, C is the speed of light in vacuum. So it is the highest value. So C equal to 1.33 times speed of light in water. Or in another words also you can say, the velocity of water decreases in water. How many times? It decreases in water 1.33 times. So this refractive index value gives this kind of information. Suppose you can see in diamond. So here the diamond is also showing the refractive index value. So the diamond value equal to 2.42, highest refractive index material. It means in this material, the speed of light compared to vacuum is less. How much less? It is 2.42 times lesser than the vacuum. We take one more example. The refractive index of a crown glass, it is 1.52. What does it means? It says that the light travels 1.52 times slower in crown glass comparatively in vacuum. So how would we know that? So if you know the speed of light in different mediums, then we can divide these two, and finally we can get these numbers. With the numbers we can understand it. So if you can read this one, the refractive index of water. So just the above paragraph from the NCERT, the refractive index of water n suffix w equal to 1.33. This means that the ratio of light in air and the speed of light in water equal to 1.33. So to know the ratios of light in two different mediums, so the very helpful physical quantity is refractive index. So refractive index is the ratio of the speed of light into different mediums. So this is the second formula regarding the refractive index. We already got one formula, so that is the refractive index mu or n equal to sin I by sin r. So with the help of sine of angle of incidence to sine of angle of refraction also we can find out refractive index, or we got now with the help of refractive index mu equal to, or we can use a symbol, both are the same. Mu is the Greek symbol to use refractive index. You can read that as MUE, mu, or we can use simply n. So refractive index n equal to, we can write a formula from this concept, mu equal to C upon V. So these two are the refractive index formulas. Depends upon the situation, we can calculate the refractive index value.